Rajita Pillai from CEC. My seminar topic is about random process and its classifications. Here, introduction to random process. A random process is a collection of random variables indexed by time. A random process is also known as stochastic process. Each sample path represents a possible outcome. Random process model time varying uncertain signals. Importance of random process. It mainly used in communication systems, finance and biology and weather forecasting, and it helps in analyzing uncertain signals and noise. Useful for predicting system behavior under randomness. These are the importance of random process. Here the basic terms of the random process. The basic terms are sample space, a set of all numbers or a set of all possible outcomes, random variable, mapping from sample space to real numbers, and random process, a set of random variables over a time. Here the mathematical representation of a random process. Firstly, the random process is a x of t comma w omega. For example, x of t comma omega, t equals to time variable, omega equals to outcome from the sample space. For each omega, x of t comma omega is a time function or a sample function. Here the sample function. Each realization of a random process is a sample function. Example, noise signal measured over a specific period, and it represents one possible behavior of the process. This is the sample function of the random process. Classification of random process. Random process can be classified that are based on time and sample space nature. It depends on time and sample space nature, statistical properties, statistical properties, stationarity, and ergodicity. Based on time and sample space, discrete time random process. Discrete time random process. Time takes discrete values. As it is a discrete time random process, time takes discrete values. And continuous time random process. Here the time is continuous. Discrete start random process. Amplitude discrete. Continuous state random process. Amplitude continuous. Here discrete state random process that takes amplitude discrete. Continuous state random process. Here the amplitude is continuous. Examples. For discrete time, daily stock price samples, and for continuous time, voltage of a noise signal. Discrete time, coin toss outcomes, and continuous state, temperature over time. Based on statistical order, first order process. Here comes three process, that is first order process, second order process, and nth order process. For first order process, statistics of a one variable, only one variable is existing. In second order process, joint statistics of two variables. Here the two variables exist in this second order process. And nth order process, joint behavior of n number of random variables. Here the mean function, mean equals to m of x of t equals to expectation of x of t. This is the formula of mean function. Here it represents the expected value at a time t, and for a stationary process, mean is constant. Here the autocorrelation function. The formula of autocorrelation function is Rx of t1 comma t2 that equals to expectation of x of t1 comma x of t2. Measures the correlation between two same variables of a random process. It is important for power spectral analysis. In this process, the function acts between two same signals or same random variables. Cross correlation function. Here, for cross correlation function, the formula of cross correlation function is Rxy of t1 comma t2 equals to expectation of x of t1 into y of t2. It measures the correlation between two different random processes. It takes two different random variables or signals. It measures the correlation between two random processes. The next concept is stationary process. In this, the property is independent of time shifting. The stationary process is independent of time shift. And next one is strict sense stationary, which is also represented as SSS. In this, all order statistics are unchanged. And next one, wide sense stationary, which is also represented as WSS. In here, mean is constant and autocorrelation depends on time difference only. In wide sense stationary, it have to prove that mean is constant and autocorrelation function depends on time difference only. And next one, non-stationary process. The statistical properties change with time. In stationary process, it doesn't change with respect to time. In non-stationary process, the statistical properties are changed with time. For example, speech signals, stock market trends, and next one, harder to model and predict. This is the whole thing of non-stationary process and stationary process. Next one is ergodic process. In this, the time averages equals to ensemble averages, and a single realization can represent the whole process. It is mainly used in practical measurements. In this process, the time averages is equals to ensemble averages, and a single realization can represent the whole process, and it mainly used in practical measurements. And the next concept is Gaussian process. In Gaussian process, every set of random variables has a joint Gaussian distribution, and it's completely described by its mean and autocorrelation functions. In this, the set of random variables has a joint tooth kind of Gaussian distribution, and this completely is described by its mean and autocorrelation functions. For example, in Gaussian process, thermal noising circuits is an example for Gaussian process. And the next one is Poisson's process. In Poisson process, counts the number of events in a discrete time, and the event occur randomly and independently. Example, table of customers or data packets. This is the whole thing of Poisson process. The applications of random process in communication systems, that is noise analysis, and in financial model and control systems and robotics, which are involved in communication systems, and the weather and population of studies, and it also involves in signal and image processing. This is the applications of random processor. Thank you.